Albert Einstein, as we all know, was a genius. For some, he even are the greatest scientific mind of all time. But what did he do? In this video, we will go over the theory he may be most famous for and that changed our view of physics. The theory is the theory of relativity is a scientific framework that describes the laws of physics at a fundamental level. It was developed by Albert Einstein in the early 20th century and is divided into two parts, special relativity and general relativity. Special relativity deals with the laws of physics in the absence of gravity. It introduced the concept of space-time, which is the four-dimensional space that combines three-dimensional space and time. The theory of special relativity is based on two main postulates. The laws of physics are the same for all observers in uniform motion relative to each other. The speed of light is the same for all observers, regardless of their motion or the motion of the source of light. These postulates have far-reaching consequences that challenge our intuitions about space and time. For example, time dilation means that time appears to run slower for a moving object relative to a stationary observer. This effect is observed in experiments with high-speed particles and has practical applications, such as in the operation of GPS satellites. Length contraction is another consequence of special relativity, which means that objects appear shorter in the direction of motion. This effect has been observed in experiments with moving objects and is a key aspect of the twin paradox, which describes the differences in aging between twins who travel at different speeds. Finally, the relativity of simultaneity means that events that appear simultaneous to one observer may not appear simultaneous to another observer. This effect is due to the fact that the speed of light is constant for all observers and is related to the concept of space-time intervals. Before we move over to the general relativity, if you like the content, give it a like and subscribe for more curious science videos. General relativity extends the ideas of special relativity to include gravity. It describes the behavior of objects in gravitational fields and introduces the concept of curvature of spacetime. The theory of general relativity has several key predictions that have been confirmed by experiments and observations. One of the most famous predictions of general relativity is the bending of light around massive objects. This effect was observed during a solar eclipse in 1919 and provided one of the first confirmations of the theory. Another key prediction of general relativity is the existence of black holes, which are regions of spacetime where the curvature is so strong that nothing can escape, not even light. Black holes have been observed indirectly through their effects on nearby stars and gas, and more recently through the detection of gravitational waves, which are ripples in spacetime that are produced when massive objects move. The theory of general relativity also predicts the expansion of the universe, which was first observed by astronomer Edwin Hubble in the 1920s. The expansion of the universe is now a well-established fact, and it has important implications for our understanding of the history and fate of the cosmos. In conclusion, the theory of relativity is a fundamental framework for understanding the laws of physics at a fundamental level. Special relativity deals with the laws of physics in the absence of gravity, while general relativity extends these ideas to include gravity. The theory has had a profound impact on our understanding of the universe and has led to many new discoveries and technologies. I hope you have enjoyed the video, and we will dive deeper into both of the two theories at a later time.